So with chapter 6, we get to look at the equation of a line in significantly more detail, and specifically we're just going to be looking at linear relations. 6.1, we look at the slope of a line, which we have up to this point talked about as being the rate of change. So rate of change of a line is technically the slope, the steepness of that line. Okay, so 6.1, slope of a line. Slope is used to describe steepness. Examples: pitch of a roof, pitch meaning how steep or slanted a roof is, steepness of a ski run, gradient of a mountain. You could also associate this with the slopes on roads, because there's always a tiny little slope on a road, even if it's a hill. The slope of a line segment on a coordinate grid, that's our coordinate grid that we plot points on, our coordinate grid, is the measure of its rate of change. So see, there's our key term there, rate of change. So remembering from chapter 5 what we know about rate of change. Rate of change is the change in the dependent variable over the change of the independent variable. I know a couple of you struggled with that on your test, but we're going to look at it so closely now and a little bit more detail that hopefully after 6.1 and 2 that you've kind of got a better handle on it. So rate of change is the change in the dependent variable over the independent variable, or if we're looking at our coordinate axes, our xy axes, it's the change in y over the change in x. And remember, the change in y is how far up and down. Ooh, that's nasty. How far, I gotta blow that up. Up and down over how far left and right. Okay, so remember, slope has a number of different ways we can describe it. Change in dependent variable over independent variable. It's the change in the y-axis over the change in the x-axis between 2 points. It's how far up a line goes or down a line goes over how far it goes left or right. Simply stated, change in the y, up and down, is the rise of the line. Change in the x, left or right, is the run. How far does it run? So we can simplify slope as to being the rise and run of a line. So between 2 points, how far does the line rise over how far does the line run or go? Okay. Couple of points here when we're looking at slope that you should remember. In order to calculate slope or figure out slope from 2 points or from a line, we need to choose 2 good points on the line and then count the slope between them and make sure that we're determining whether it's positive or negative. Now, choosing those 2 good points, what do I mean by good points? Good points are points on the graph or points on the line that fall at intersection points that we can easily read. So if I look at example 2 here, okay, choosing 2 good points, I would not necessarily want to choose this point right here, nor would I want to choose this point right here or this point right here, because they're very difficult to read from the graph. I could get a pretty good estimate as to what those points would be, but they're not very good points because they don't cross intersection points on the graph very well. So what I would do is I would choose probably this point right here, and then maybe way over here, this point right here. Okay? Because they're at intersection points that are very easy to read. I could probably even choose this one right here. So any of those 3 points would be 3 points that I would choose. Okay? So because that's example 2, we'll come back to that in a second. I'll leave those 2 points noted because I am going to use those to calculate the slope. Let's look at example 1. Determine the slope of each line segment. So my first step is to choose 2 points on the line. Well, we have many, many points that are perfect or nice points on this line. Here, 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 and well, we don't know where that extends. So we have about 6 different points that we could choose, and they're all good points to choose. When I'm looking at slope, I always try to spread out my points a little bit, just so I can get a fairly decent representation. There's nothing wrong with counting slope from this point to this point, okay? Or this point to this point. But I like to spread it out a little bit just so I can make sure that I get a fair representation of what the actual slope would be. So I would count the slope between this point and this point here. If I do that, I look to see, okay, I know that slope is equal to rise over run. How far up and down does that line go between those 2 points? So how far up and down does that line go between 2 points? This is my rise. Between those 2 points, that's how far up that line went. How far up did it go? 1, 2, 3, 4. Over my run, between those 2 points, how far did that line travel, left or right? My run. Again, 4. Now, if you're counting your slope properly, you really shouldn't have to worry about positive and negatives. Because if I'm going up, I'm going to count positive. If I'm going down, I'm going to count negative. If I'm going right, I'm going to go count positive. If I'm going left, I'm going to count negative. But just as a very quick ending, just to make sure that you did count things right, just look at your line. Okay? And the notes at the bottom here indicate a couple of rules that you should remember. When a line segment goes up, left to right, both x and y are increasing. Both the rise and the run are positive, so the slope of the line segment will be positive. So going up from left to right is positive. When a line segment goes down to the right, y decreases as x increases. The rise is negative and the run is positive. So the slope of the line segment is negative. So going down left to right is negative. So I know that this line here should have a positive slope. Did I end up with a positive slope? Well, I have 4 over 4, which actually reduces to 1 over 1. We never write that 1 on the bottom, so it's 1. And is it positive? Absolutely. So the slope of my line in this case is positive. Okay. If I look at my second graph over here, again choosing 2 points, 2 good points on my line, and I will just quickly sketch in my rise and my run. So here is my rise, here is my run. How far up did that line go? So slope equals rise over run. How far up did that go? Or how far down in this case? So from here to here, this direction is going down, so it should be negative 4. And we move from left to right, that should be 10. So negative 4 over 10. And then a quick thought in my head, okay, do I have a negative value? Yes, negative 4 over 10. Does my line go down from left to right? Yes, it does. So I know I'm going to have a negative slope. I know I have my positive and negatives correct. Now my last thing over here that I need to do, anytime we have fractions that can be reduced, I simply reduce that fraction. Negative 2 over 5. And that's my slope. Okay. Come back in the next video with example number 2.